everyone. Hello lovely students. Welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So we have got these two questions for today's session and we have to find the domain. Now I request you all to pause the video, read these questions carefully and try to solve them on your own. Alright, now let's solve these questions with me. And before we get into solving, I would like to specify that we're going to use some properties of modulus function for finding the domain of both of these functional expression. And that's why I request you all once again to watch my previous videos where I have taught some basic properties of modulus function. And there's one more property that was left in that video which I am covering in this one. So let's do that. So let's suppose we have let's say an inequality mod of x greater than 2 and less than 5, and we have to find the values of x which satisfy this inequality. So how do we do that? For this purpose, let's draw the number line which is running from negative infinity to positive infinity, and with respect to this inequality we'll mark some important numbers on this number line just for the ease and the convenience of our solution. So we mark 0, we mark positive 2 and positive 5 on the right side of 0 and negative 2 and negative 5 on the left of 0. Now we try to search some values of x from this number line and we'll put it in the inequality and we will verify whether our inequality is stands true for those values of x or not. If it stands true for those values of x, then those values of x will be solution for our inequality. So if you take any value of x from this interval negative 5 to negative infinity or 5 to positive infinity, let's see what's happening. So we're talking about this interval, the extreme left and the extreme right interval that I have marked. So let's say we take negative 6 and positive 6 and we put in the inequality and see what's happening. So we'll verify what's happening. So the modulus, you all must be knowing that it always gives a positive output. So mod of minus 6 will be 6 and mod of 6 will be 6. So you can see for both the inequalities this is wrong because 6 is greater than 2 but it is not less than 5 here as well. So any number, if you take from this interval negative infinity to negative 5 and 5 to positive infinity, it will not satisfy this inequality. So this interval, any value of x from this interval will never be a part of this inequality solution. So we reject this. Okay, we reject this. Now we'll try to put some values of x from this interval, negative 2 and to positive 2, and we'll see what's happening. So let's take some values of x. Let's say we take negative 1 and positive 1 and we put it in the inequality and we verify what's happening here. So we put negative 1 and we put positive 1 as well in the given inequality. So modulus of negative 1 will be positive 1 and modulus of positive 1 will be positive 1 only. So you can see here that this is the wrong one because 1 is greater than 2. It says 1 is greater than 2, which is a wrong statement. Okay, the other part is right, but the inequality stands true when both the parts are right. So one is right, the other one is wrong, the whole inequality will be false. Same here as well. So we reject this interval, negative 2 to positive 2, because any number or any value of x from this interval is not satisfying our inequality. Now we are left with only this interval actually, this one. Okay, so just let me mark it more clearly. So we are left with negative 5 to negative 2 and 2 to 5. Now we take some numbers from this portion of number line and we'll see what's happening here. So let's say we take negative 3 and we take positive 3 and see what's happening here. So when we take negative 3, so the modulus of negative 3 will be 3, then equality stands true. And when we take positive 3 also, and we verify, inequality stands true. So if you take any value of x from these two intervals, negative 5 to negative 2, union 2 to 5, then inequality stands true. So the solution for this inequality is x belonging to negative 5 to negative 2, union 2 to 5. Now we can generalize this by saying, just give me a few seconds to fix this. Alright, so whenever we have mod of x greater than a and less than b, where a and b are positive reals, so the value of x comes out to be negative b to negative a union a to b. Now you have to memorize this. Now I'll say a better way to memorize this value in a much smarter way. So let's say you have mod of x greater than a and less than b once again, and you have to write the value of x. So this can also be written as mod of x belonging to a to b, right? In the interval form we can write it in this way. So for x, what you have to do is you simply write this interval a to b as it is with a union sign on the left, and you multiply this interval with a negative sign. So when you multiply this interval with a negative sign, the left hand and the right hand boundary point will be reversed. So you have negative b to negative a, and that's all. And this is what we were getting here as well. So it is a much smarter way to memorize. So I request you all to memorize this using this logic. Now what if we have equality here? So again, let's write it in the interval form. So we have open a and b close. Now for x, we'll write this interval as it is and with a union on the left side, and we multiply with a negative sign. So when we multiply with a negative sign, the left and the right hand boundary point, they are reversed. So we have negative b to negative a open, and that's it. Let's take some more situations. Now what if the inequality we have at a and inequality at b? So again, let's write in the interval form. We have mod of x belonging to close a to open b. So for x, we'll write this interval as it is and with a union on the left side, and we multiply with a negative sign. So we have negative b to negative a, and we'll close it. Hope you understand. Alright, now let's get back to the solution part of the question. So the first question we have, what was the question? Okay, so we have 5 mod x, solution of the first one. So we have 5 mod x minus x square minus 6. It's a square root expression. So whenever something is written inside a square root sign, in order to define that functional expression, we have to make sure that the expression inside the square root sign, it is either positive or equals to 0, greater than or equals to 0. Now you all must be knowing that x square can also be written as mod of x square. So in place of x square, we can write mod of x whole square minus 6 greater than equals to 0. So whenever you come across this type of situation, you have to follow this working rule, which I am saying it here just now. So let's say mod of x is equals to t. So we have 5t minus t squared minus 6 greater than equals to 0. Now it is advisable that whenever you come across quadratic inequalities, it is important to make the coefficient of t square, x square or y square, whatever is the variable. Like here we have t. So we have negative t square. So we'll make it positive by multiplying it with a negative 1. And when we do so, You all must be knowing that whenever we multiply inequality by a negative sign, the sign of inequality is reversed. So greater than equals to 0 becomes less than equals to 0. Now we factorize this using middle term splitting method that you all are taught in your earlier classes. So we have t minus 2 into t minus 3 less than equals to 0. Now we draw the wavy curve for the left hand side expression, and I have taught the wavy curve, how do we draw the wavy curve in detail in my previous videos, and I request you all to watch my previous videos once again so that you may understand it in a much better way. So we draw the wavy curve. We mark the critical points on the number line by equating all the linear factors to 0, which is the working rule of wavy curve, and we start drawing the curve. We change the sign alternately because it's a working rule of wavy curve. Whenever the linear factors corresponding to the critical points, they have odd power, you have to change the sign from positive to negative or from negative to positive. And because all the linear factors, they have odd power, the power is 1. So whenever a power for a mathematical quantity is not written, it is by default actually taken as 1. So we change the sign, and the left hand side expression, we want it to be less than or equals to 0. So if you observe the wavy curve carefully, in the interval 2 to 3, the wavy curve is below the number line, which tells us that in this interval, the expression will achieve a negative value, and this is what we want. So t lies in the interval 2 to 3. Now we have to take 0 as well, because this expression, the left hand side expression, should be negative or it should be equals to 0. It should be negative or it should be equals to 0. So 0 as well we can take. So for that reason we have to include 2 and 3 in our solution. So to include 2 and 3 in our solution, we simply do what? We make these round brackets as a square bracket. So now 2 and 3 will be a part of a solution. And t is actually mod of x. So mod of x is 2 to 3. But we want the values of x, because x is the variable in the original functional expression and the values of x will be the domain. So just a couple of minutes back I was saying how to get the values of x if mod of x is given in this way. So we'll just write this interval 2 to 3 as it is with a union on the left side, and we multiply this with a negative sign, this interval, to get negative 3 to negative 2, and that's all. This is the domain for our required functional expression. Now let's solve the second one. The second question we have fx is equals to 7 minus mod x. Okay, so the second one we have, it's very simple, and we use one property of modulus function that I have already taught in my previous video. So in my previous video I have taught you that whenever you have mod of x less than a, you can write x belonging to negative a to positive a, and if you have an equality sign, just you will include the left hand and the right hand boundary point. So you make these round brackets as a square bracket. So the second functional expression, we have 7 minus mod x inside the square root sign. So to define this square root, we have to make sure that 7 minus mod x is greater than or equals to 0. Now we have 7 greater than or equals to mod x, which in other words can also be written as mod of x less than or equals to 7. So we can directly write, following this, we can write x belonging to negative 7 to positive 7, and that's all. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all my lovely friends in my next upcoming videos with more exciting and a lot of awesome questions. Till then, bye bye, stay safe and have a nice day.